We need to start out in statistics with some basic vocabulary. So let's take a look at this definition of individuals and variables from the book. Individuals are the objects described by a set of data. Individuals may be people, animals, or things. A variable is any characteristic of an individual. A variable can take different values for different individuals. Then we want to look at two types of variables, categorical variables and quantitative variables. A categorical variable places an individual into one of several groups or categories. A quantitative variable takes numerical values for which it makes sense to find an average. So let's take a look at the data we collected in our class survey. Who or what are the individuals in the class survey? Well, the class survey was asking you questions about yourself, so you are the individuals. The AP Stat students are the individual in this set of data. Now the variables are all the different questions I asked of you. What's your gender? How many siblings do you have? What's your zip code? What's your dominant hand you write with, etc. So all of these are variables about you, the individual. Now we're going to categorize these variables or divide these into categorical and quantitative variables. So what I'm going to do is every categorical variable I'm going to put a box around, and I'm not going to put any marking next to the I'm going to put a Q actually next to the quantitative variable. And the reason I'm not going to put a C next to categorical is because quantitative variables come in two types as well. They are discrete and continuous, so I'm going to use D for discrete and C for continuous. Okay, so let's start by categorical. What values of the variable just divide you into categories? Okay, well, gender, clearly, male or female. Let's see, birth month. Okay, that's clearly a category, January, February, March, April, etc. Type of pet. Okay, that would be a category. Those would be categories. Now there's a couple things, there's a couple others, maybe, dominant hand, left or right hand, that would also be a category. Now there's one numerical value that's actually a category, and that is zip code. And so let's talk about why that one is not quantitative even though it is numerical. Quantitative variables have a meaningful average value. It would not be meaningful to average our zip codes. Actually, before I finish writing this, the word that we use for average in statistics is mean. So when we say the mean value, we're talking about the average value. A zip code would not have a meaningful average. It would not make sense to add up all your zip codes, divide by the number of students, and say this is the average zip code in the class. That makes absolutely no sense. So a zip code is just a numerical label. So when you have a numerical label, it's still categorical. So all the rest are quantitative. You could find the average number of siblings in a family, the average age that people guess my youngest child to be, the average amount of sleep, the average height, the average number of kernel of corn guessed by students. So all of those make sense. So those are all quantitative variables. So I'm going to put a Q by all of the other ones. Now we need to decide if they are discrete or continuous. Discrete are a fixed set of possible values with gaps in between. Continuous means they can take on any value. Now some of these are a judgment call and kind of depends on how you're defining that data value. But number of siblings is definitely discrete. I guess I'm going to go ahead and write that out. It's definitely discrete because you can't have 1.5 brothers, okay? You can only have one brother or two brothers, but you can't have 1.5 brothers. The age of Mrs. Taylor's youngest child. Probably in the way I'm defining it, discrete, okay? So it's not going to be, it would not make sense that my age of my youngest child would be, there's pretty much a range of values that make sense. Like my youngest child is not going to be 82 years old. And I'm not asking for half years, so we'll call this one discrete as well. Okay. Amount of sleep. Now I did say to the nearest whole number and the nearest half number. I can't remember how I define that, but could you sleep like 1.2 hours, 1.25 hours? Yes. This is a there are all possible values of amounts of sleep in between other values. Same thing with height. Height is also a continuous variable because you could be 59.5 inches, 59.75 inches, and so forth. Number of kernels of corn, once again, that's discrete because when you're counting kernels of corn, that's going to be a whole number value, okay? So that kind of lets you know the difference between discrete and continuous. And we're not going to do a whole lot with that right now, but I just wanted you to be familiar with that term. The other thing I want to introduce is something called the distribution of a variable. The distribution of a variable tells us two things: what values the variable takes and how often it takes each value. So we'll look at some examples of that in the next video.